Okay, the students learned the reverse box method for two-digit two-number multiplication. Excuse me. Yesterday. So now today we're working on the traditional box method, or better known as box method. So I'm going to go through this fairly quickly, and I'm just going to use the same problem that I did with the one yesterday. So first we need to start the same way as we did yesterday and set up a 2x2 box, 2 rows and 2 columns, since each number has 2 digits. Now we're going to separate out our 15 into 10 and 5, just like we did with the other method. But this time we're going to align it with place value. Whereas we did little big yesterday, we're going to do like 10s, 1s, okay? So our 15, that's a 10 and a 5, and our 11, that's a 10 and a 1. So we're going to do our 15 on top here, and we're going to do 10 plus 5. And then with the 11, we're going to do 10 plus 1 and multiply them out just like we did yesterday. Okay, and now we're going to add our rows together just like we did with the other one. So 100 plus 50 equals 150. 10 plus 5 equals 15. And then we need to add these two together. So we have 5, 6, 1, and the answer is 165. And I will go ahead and grab another color and show you how this can play in to the traditional multiplication. So 15 multiplied by 11, we have 1 times 5, which is 5, or 1 times 1, which is 1. Then come down to the second row and add our 0 and do 1 times 5 and 1 times 1. Then add these together. And as you can see, the answer is the same, and these are just crossed. See? So it's really the same thing. I'm going to do one more really quick, just to show you. Sorry, this is my little eraser. So it takes me a second. Okay, so I'm going to do the same problem again that we did as the second problem, I believe, yesterday. I believe it was 13 multiplied by 12. 2x2 box. Okay, and separate out our 13 to 10 plus 3 and place them in the 10s and 1s spaces. And separate our 12 out into 10 plus 2, 10s, 1 spaces. Multiply the 10 times 10, which is 100. 10 times 3, which is 30. 10 times 2, which is 20. And 2 times 3, which is 6. And I wouldn't write them diagonal like that, but that's just how it's turning out with me writing from an odd angle. 100 plus 30 equals 130. 20 plus 6 equals 26. And we want to keep them lined up so that it's easier to add. 6 plus 0 is 6. 3 plus 2 is 5. And then 1. So the answer to this problem is 156. And I'll show y'all again how it ties into the traditional method, even though our kids haven't quite learned that yet. 2 times 3 is 6, 2 times 1 is 2, add our 0, 1 times 3 is 3, 1 times 1 is 1, add them together, 6 plus 0 is 6, 2 plus 3 is 5, and 1. So as you can see, the answer is the same, and these are just crossed. So now the potential errors that students can make, they're really the same as they were with the reverse box method, just mostly mental math errors, like adding this 100 plus 30. Sometimes when they do that in their head, they want to do it left to right like we read, but that's not how we add our numbers together. So they'll think to themselves, okay, 1 plus 3 is 4, then 0 plus 0 is 0, 0. Well, that's clearly not 100 plus 30. So if that's a problem, I just suggest for the student to come over here and just line it up like they would a traditional addition problem, if that is, a problem, an error they're making, and write it out just like that. So no big deal, that's fine. Another concern we have sometimes with the parents are, well, if you taught the reverse box method and the traditional box method, and they're so similar but still different, don't you think that's going to cause confusion and errors? Not really, because it could cause an error, but it's not going to be an error. So say they're thinking traditional box method, and they do their 10 plus 3 out just like that, but then they get confused and think of the reverse box method, and don't do their big number first. They come over here and do their little number first. So they do 2 plus 10 for the 12. But when you multiply all that out, you still end up with the same answer. So it's A-okay. That's teaching them the cumulative property of multiplication. So they're getting a head start there. So that's okay. That's not something that I would count off for. The answer was right. We do teach different strategies, but we want to get to the answer. That's the most important thing. And we want them to understand. We want them to understand why they're getting the answer. That's the most important thing. That's our goal. We don't want them to just memorize a formula and not understand and then forget it, because that's what happens a lot of times. Or make errors because they forgot a step. We really want them to gain that conceptual knowledge, and that's what this, as well as the traditional, this is the traditional, but as well as the reverse, that's really what it's teaching them. It's helping them gain that conceptual knowledge of what's really going on here.